So good evening, welcome to CIRCLES01 YouTube channel. Rahul, Mahendra, Avinash, Umar Farooq, Swati Singh, Hanma Reddy, Ishwar Chandra, Sakala Rahul, Ishwar, Karthik, Manikanta, Yama, Rakshita Gaud, Swati Singh, Vamshi Krishna Yadav, Vignesh, Kirtana, Vandana, Balu, Nageshwar Reddy, Kirtana, Sadvika, Prasanna, Jashwant, Shamala, Vamshi Krishna Yadav. Okay, welcome. Kartikeya, Siddhartha. Calculus has been completed. Already Siddhartha. Turgan Lohita, Balu Simili. So Akash Kadamba. Rahman. Okay, Akash Kadamba. Okay, good evening all. Good evening, Pushpa. So New Years are there. You need to subscribe, like, subscribe and share. Prudvi, Suma, good evening. Turgam Lohita. Kopi Chand. Asrit. Yes, Durgam Lohita. CH Munaya. CH Munaya. Okay. Weightage of this chapter, circles, 3 to 4 marks in the examination. Thank you, Srikant. Vaishnavi, good evening. Okay. Hamad, Revati. Right. Thank you. System of circles. This is the part of the circles only. System of circles, part 1. Today we talk about system of circles. System of circles. Okay, Pushpa. Right. So now let us draw a circle. Okay. So this is the circle. Okay. So now this is center. This is called radius. Radius. Say this is C. Say this is C, this point is P. Say this is R, radius R. Okay. See now, equation of the circle, is x square plus y square plus 2gx plus 2fy plus c equals to 0. This is called standard form. So standard form means x square coefficient is unity and y square coefficient is unity. Then from this one we can find out center is given by minus g comma minus f. That means minus half of the x coefficient minus half of the y coefficient, minus g comma f. Radius is given by root over g square plus f square minus c. This is very important points regarding to the one circle. Understood now? So this is the circle. Generally this is denoted by s is equal to 0 also. This s means, once again you remember, x square plus y square plus 2gx plus 2fy plus c. Okay, now for example, take one circle. Now another circle. Say this is circle 1, this is circle 2. For example, circle 1 and circle 2. Say, suppose okay, let the center of this circle is equal to say C1. Say point is P. For example, center of this circle is C2. This is something say Q. See, radius of this one is equal to R1. So radius of this circle is equal to R2, for example. So now we need to discuss the position of one circle with respect to other circle. So we talk about the position of one circle with respect to other circle. So for example, this radius of the center is equal to center of the first circle is, for example, first circle, this is first circle, this is second circle. Here center equals to say C1, radius equals to say R1. Here second circle, center is equal to C2, say radius equals to R2. Consider here, R1 is greater than R2. R1 is greater than R2. Okay. So now here actually different cases will arise. So different cases will arise means we need to discuss the different cases now. So different cases of the positions of the one circle with respect to other circle we need to discuss. Okay, now this is the one circle. Take another circle. So what is the position of circle here now? This, say here now, say this first circle, for example, this is S is equal to 0. Say this is S dash is equal to 0. Now say this is case 1. Case 1. Case 1. Here in case 1, if you observe, for example, this is the center, for example, say this is C1, this is radius R1, this radius is R2. So if one circle lies other circle, if S dash is equal to 0 lies inside of S is equal to 0. That means here actually one case will arise. Sorry, say this is R1, this is R2. R1 minus R2 will be greater than here the distance between the centers C1, C2. R1 minus R2 greater than C1, C2. Now how many number of tangents can be drawn from this one? They are concentric circles, okay? How many number of tangents can be drawn? Here number of tangents is equal to number of tangents is equal to 0 tangents can be drawn. So we cannot draw any tangent. Okay. So now let us move to next one. Case 2. Let us discuss case 2. Case 2. Here now take the circle like this. More circle. Here one circle touches other circle inside. So that means in this case actually we can consider here, see here R1 is greater than R2. So this is the radius of this circle. S is equal to 0. This will be S dash is equal to 0. R1 is greater than R2 here consider, and also here R1 minus R2 equals to C1 C2. C1 C2. Distance between the two centers. Distance between the two centers. For example, you take like this. Okay. For example, say this is C1, center of this circle is C2. The C1, C2 will be equals to R1 minus R2, difference of the radii. Then actually here how many number of tangents can be drawn means here number of tangents, you see here actually we can draw one tangent. one tangent can be drawn. So therefore, in this case, number of tangents can be drawn is equal to one tangent. One tangent can be drawn. So now okay. Now you do one thing. Here case 3. You consider case 3. Case 3. So in the case 3, for example, if one circle is like this, for example, other circle is like this. Other circle is like this. See, now you join the centers of these two circles. This is C1, this is C2. Say this radius is R1, this radius is R2. Here now we have R1 minus R2 will be less than the C1 C2 is less than R1 plus R2. That means these two circles do not touch each other. So how many number of tangents can be drawn means actually here see, here one tangent, here also one tangent, and we can draw the tangents like this also. And we can draw the tangents are like this. So that means here number of tangents is equal to 4. And one more thing here, these two tangents are actually here, green tangents are called direct common tangents. Direct common tangents. See, direct common tangents is equal to 2. And next, these are called transverse common tangents. Transverse common tangents. Transverse common tangents is equal to 2. Total 4 tangents can be drawn. So at most actually for two circles, 4 tangents can be drawn. 2 is direct common tangents and 2 is transverse common tangents. Right. Next, for example, case 4. For example, you take a circle like this, bigger circle, you take a smaller circle. Okay. This is a smaller circle. Both intersected 2 points. Now C1, this will be, C1 is the center of the first circle, C2. Suppose this say R1 its radius, R2 will be the radius. And next now the relation we have here, we have C1 C2 will be greater than R1 plus R2. C1 plus C2 is, sorry, in the previous case actually we did mistake. So this is actually wrong. I have taken wrong. Here condition is wrong I taken. Please try to understand. Here C1, C2 is greater than R1 plus R2. So then we get this condition. Okay, next now for this one, R1 minus R2 is less than C1, C2 less than R1 plus R2. Then actually see here one direct common tangent, other direct common tangent. No transversal common tangent. So the number of tangents can be drawn is equal to 2. Therefore, number of direct common tangents is equal to 2. Number of transverse common tangents is equal to 0. Understood now? This is case 4. Case 5. See in case 5, for example, this is circle, this is another circle. Touch externally. Suppose, say this is C1, this is C2. Now touch at P for example. This is R1, radius is R2. Here clear, we have R1 plus R2 equals to C1, C2. Therefore, here how many number of tangents means? One direct, other also direct, and one more common tangent here we can find out. Total 3 number of tangents is equal to. So the number of tangents is equal to 3. That means direct common tangents is equal to 2. Transverse common tangents is equal to 1. Total 3. That means actually in this case they touch each other externally. So now the case 6, let us have a discussion on case 6. See, case 6 means, for example, this is the circle, other circle touches internally. This we can write, we have here R1 minus R2 equal to C1, C2. Then they touch internally. So number of tangents is equal to only one tangent can be drawn. Only one tangent. So the number of tangents is equal to here one tangent. 1. You will be getting 1. Okay, these cases will arise. Okay. Next now, centers. We need to discuss, we talk about centers. Centers is actually two types. External center of similitude and internal center of similitude. So we talk about these two things. What is meant by external center of similitude? What is meant by internal center of similitude? So for example, see, the two circles like this, for example, two direct common tangents can be drawn. So they meet at point, say, I1. So now you join their centers. This is C1, say this is C2. Okay, perpendicular. This also perpendicular. Say radius is R1, this radius is R2. Okay, so that means the point of intersection of the direct common tangents of the two circles is known as external center of similitude, denoted by I1. So how to find out I1? For example, I1 is called external center of similitude. So I1 divides C1 C2 in the ratio R1 is to R2 externally. Therefore, now this I1 is given by like this. For example, center is x1 comma y1. This center is, we can say, x2 comma y2. Now the line segment joining x1 comma y1 and x2 y2 is divided by in the ratio R1 is to R2. So we get like this: R2 x1 minus R1 x2 upon R1 minus R2. This is actually R1 x2 R2 x1, R1 y2 minus R2 y1 upon R1 minus R2. Using this formula, we can find out external center of similitude. So now, see, for example, this is the circle. This is another circle. So for example, join these centers. Okay. So now this is transversal common tangent. This transversal common tangent meet at this point. So the point of intersection of the transversal common tangent is called internal center of similitude. For example, say the previous case better, you can say I2. This is, say, I2. You say I2. Okay, now say this is I1. Now center C1. This is center C2. So now they say the radius R1 first circle, radius of the second circle, say R2. Now here I1 is called internal center of similitude. So I1 divides C1 C2 in the ratio R1 is to R2 internally. See, for example, let us say C1 coordinates are x1 comma y1, C2 coordinates are x2 y2. So what is I? what are the coordinates of I? So that means now I1 equals to given by R1x2 plus R2x1 upon R1 plus R2, comma R1y2 plus R2y1 upon R1 plus R2. This we can find. And one more thing now. See, for example, this is the bigger circle. For example, this time take the smaller circle, for example. Draw say for example this is P, this point is Q. What is length of direct common tangent? Length of direct common tangent is given by, what is the formula? See, for example, distance between the centers C1 and C2, say this is D, the distance between the centers is say D, C1 C2 is equal to D. For example, radius of the first circle is R1, radius of the second circle is R2, for example R2. Then the length of the direct common tangent is given by the formula root of d square minus r1 minus r2 whole square. This is the formula to find out length of the direct common tangent. So now, for example, for this one only, transversal common tangent you try it. Transversal common tangent. Say for example this is RS. So length of transversal common tangent. This is given by same root of d square minus r1 plus r2 whole square. That means with the help of these two formulae, we can find out length of the direct common tangent, and length of the transversal common tangent. These two formulae are very, very important. So if you want to find out the length of the direct common tangent and length of the transversal common tangent, directly you shall not be given d value, r1 value and r2 value, but you need to find out radius of the first circle r1 and center of the first circle c1. And second case, you need to find out radius of the second circle r2 and center of the circle c2. Then the distance between the centers we need to find out, that is d, using distance formula, and then using these two formulae we can find out length of the direct common tangent and length of the transversal common tangent. Okay, now right, let us move to the next concept now. Let us move to the next concept. Okay. For example, this is first circle. This is second circle. Actually, they cut each other. These two circles cut each other. For example, say the equation of this first circle is s is equal to 0. Equation of second circle is s dash is equal to 0. Say, for example. See now, this is one point, other point. Say this point is P, point of intersection of first circle and second circle, say P. Other is say Q. At P, Can we draw a tangent? Yes, we can draw a actually tangent. So let us draw a tangent at P. So we have drawn a tangent at P. So now one more tangent also we can draw at P. To the this is second circle, this is the first circle we have drawn. So now what do you observe here? A angle will be formed between the tangents, say theta. So now theta is called angle between two circles. S is equal to 0 and S dash is equal to 0. Now we talk about the angle between the two circles. How to find out the angle between the two circles. So now angle between the two circles. Between two circles. So what is the formula? So let us think about the formula. So now the formula is given by, so for example, so cos theta is given by, for example, say this is C1 and C2. C1 is the center. So radius of the first circle R1, radius of the second circle R2. Now D is equal to C1, C2. Now cos theta is given by D square minus R1 square minus R2 square to R1 R2. This is the formula to find out angle between the two circles. Angle between the two circles. So otherwise you can say theta is equal to cos inverse of D square minus R1 square minus R2 square upon 2 R1 R2. This is mod. This is the modulus of this one. So this is the formula to find out angle between the circles. Okay, now we know that cos theta is equal to modulus of D square minus R1 square minus R2 square upon 2 R1 R2. Suppose if theta is equal to 90 degrees, what happens? Let us see. If theta is equal to 0, cos 90 becomes what? 0. Obviously this becomes 0. So therefore we get D square minus R1 square minus R2 square upon 2 R1 R2 becomes 0. Cross multiplication, D square minus R1 square minus R2 square equals to 0. So we get D square equals to R1 square plus R2 square. Suppose if D square is equal to R1 square plus R2 square, then the angle between the two circles is 90 degrees. If the angle between the two circles is 90 degrees, they set to cut orthogonally. They are orthogonally each other. So that means if D square is equal to R1 square plus R2 square, then two circles cut each other orthogonally. That is theta is equal to 90 degrees. This is very, very important point. Okay, now next point. For example, this is a circle, first circle. Take this as second circle. Say S is equal to 0. The equation of this circle is. Say the equation of circle is S dash is equal to 0. See now, here let us suppose S equals to x square plus y square plus 2gx plus 2fy plus c equals to 0. S dash is equal to x square plus y square plus 2g dash x 2f dash y plus c dash equals to 0. Now find s minus s dash is equal to, what do you get now? S minus s dash, x square cancel, y square cancel. You get like this, 2 times g minus g dash of x plus 2 times f minus f dash of y plus c minus c dash equals to 0, c dash. So equate to 0. For example, it will be in the form of ax plus by plus c equals to 0. So represents an equation of a line, So now this is called, radical axis of s is equal to 0 and s dash is equal to 0. Generally the radical axis will be like this. For example, this is C1, this is C2. So you join C1, C2. So then this will be radical axis. This will be perpendicular to C1, C2 itself only. C1, C2. This is radical axis. Radical axis is nothing but a straight line. Represent a straight line. So which is in the form of ax plus by plus c equals to 0 form. Understood now? How to find out radical axis of two circles? Very simple. First you need to check s is equal to 0 must be in standard form. Standard form means x square y square coefficient must be unit. S dash 0 must be in standard form. X square y square coefficient must be unity. Then subtract one equation from other equation and equate it to 0, so that we get equation of the radical axis. Understood now? So that means now, different cases. For example, this is the first circle, this is second circle. First circle cut the second circle. Say this is s is equal to 0. This equation is s dash is equal to 0. Now through point of intersection we can join a straight line like this. Say this is P point, say Q point. This PQ is known as common chord. So now here radical axis is s minus s dash is equal to 0 is the common chord of two circles s is equal to 0 and s dash is equal to 0. That means if the equations of the two circles are given, then the equation of the common chord is nothing but radical axis itself only. So if the two circles cut each other, then the radical axis is nothing but It's common chord only. It's common chord. So now, for example, two circles touch externally like this. Touch externally. Touch externally. Now we have the common tangent. This is a common tangent. So how to find out common tangent means same here also we can write. In this case, radical axis is s minus s dash is equal to 0 is the common tangent. Common tangent of two circles s is equal to 0 and s dash is equal to 0. S is equal to 0 and s dash is equal to 0. Even the two circles touch internally also like this. In both cases, same. For example, this is the common tangent. So in these two cases, the common tangent is given by s minus s dash is equal to 0. So now here common chord, it is called common chord. For example, the two circles are like this. This is called radical axis. Radical axis. Okay. One more thing you remember. See, this is the circle. This is take another circle. For example, C1 and C2. This is called radical axis. Radical axis. Radical axis. Say this s is equal to 0 and s dash is equal to 0. So one important point is actually radical axis is perpendicular to this. The line joining C1 C2 is called line of centers. Line of centers. Line of centers. So that is, for example, this radical axis say L is perpendicular to C1 C2. C1 C2. This we can observe. Okay. Next. For example, this one circle, take another circle, three circles you take it now, three circles. For example, center of this circle is C1, center of this circle is C2, center of this circle is C3. Say the equation of this one is s is equal to 0, the equation of this circle is s dash is equal to 0, equation of this circle is s double dash is equal to 0. The three equations of the circles are given. For example, now you find the radical center of these two circles and radical center of these two circles. Radical center of these two circles. They meet at one point. This point of concurrence of the, we can say like this. Say this point is, for example, P. The point of concurrence of the radical concurrence of the radical axis of three circles whose centers are non-collinear. C1, C2, C3 are non-collinear. Non-collinear. Non-collinear is called radical center. Radical center. So now how to find out radical center of the three circles? How to find out the radical center of the three circles means first what we need to do it now. See, first s minus s dash is equal to 0. We get one equation. S dash minus s double dash is equal to 0. We get second equation. Solving 1 and 2. We get radical center. Like that we can find out the radical center. So one more the property from radical center, for example P, you draw tangent to the first circle, second circle, third circle. Say PA, PB and PC. Here we observe that PA is equal to PB equals to PC. The length of the tangents drawn from radical center to the three circles are equal, same. Understood now? PA equals to PB is equal to PC. The radical center, the length of the tangent drawn from P to the first circle, second circle, third circle are same. PA is equal to PB is equal to PC. Okay. Now problems. So let us go for the first problem. First problem. First question. If radii means plural for radius, radii of two circles are 4 and 5. Sorry, 4 and 3. 4 and 3. And distance between the centers is root over 37. Then the angle between the circles is this is the question. Okay, first option is 30 degrees, second option is 45, third option is 60, fourth option is 90. Right. Radii of two circles are 4 and 3. The distance between the centers is root 37. Then the angle between the circles we need to find out. That means what is given here? R1 equals to 4, R2 equals to 3, D equals to root 37. Let theta be the angle. Cos theta is given by modulus of d square minus r1 square minus r2 square upon 2r1 r2. So this equals to d square means 37 minus 16 minus 9 upon 2 times 4 times 3. So you are getting positive value, you remove the modulus sign, no problem. 37 minus 25. How much you will be getting? 12. So 12 upon 2 times 12. That's equal to 1 by 2. Therefore, theta is equal to 60 degrees. Am I correct now? Theta is equal to 60 degrees. So we have third option is the right option. Second problem. Angle between the circles, x square plus y square minus 4x minus 6y minus 3 equals to 0 and x square plus y square plus 8x minus 4y plus 11 is equal to 0 is, this is the question, right? First option is pi upon 3, second option is pi upon 6, third option is pi upon 2, fourth option is 5 pi by 3. This is the question, right? Angle between the circles x square plus y square minus 4x minus 6y minus 3 is equal to 0 and second circle x square plus y square plus 8x minus 4y plus 11 is equal to 0. See, in order to find out this one, actually what we need to do means we need to find out actually here center and radii of the two circles we need to find out. So that means, so here first let us find out solution. Here first circle, next here write down second circle. First circle center C1 equals to half of the x coefficient minus half of the y coefficient, 2 comma 3. Am I correct? C2 is equal to minus 4 comma 2. Next radius R1 is equal to root of 4 plus 9 plus 3. This R2 is equal to g square 16 plus 4 minus 11. So this will be 13, 16. So 4 you will be getting. This will be how much? 20 minus 9, 3. Now find D. D equals to distance between C1 and C2. This is equal to root of minus 4 minus 2 minus 6 square 36 plus we have 2 minus 3 1, that will be root 37. Same previous question, understood now? R1 is equal to 4, R2 is equal to 3, D is equal to 37. So we get cos theta is equal to 1 by 2. That's equal to cos 60 degrees. Cos 60 means pi by 3. Theta is equal to pi by 3. So first option is the right option. Same only. Third question. Third one. The angle between two circles, each passing through the center of other is. First option pi by 6, second option pi by 2, third option is 2 pi by 3, fourth option pi. So let us draw the figure first of all now. Here see, this is one circle. So now other circle is passing through like this. So what it implies that second circle passes through the center of the first circle passes through the center of the second circle. C1, C2. This C1, this is C2, C1, C2. So that means C1, C2 equals to what now here we get now? It's clear that if you say C1, C2 equals to D, now radius of the both circles are equal. R1 equal to R2 equal to R. Now cos theta formula. What is the cos theta formula? Modulus of D square minus R1 square minus R2 square upon here 2 R1 R2. It's clear that this is D. D is also equal to D. R is equal to D. Now substituting here we get D square. D square means R square minus R square minus R square by 2R square. Mod R square cancel. So R square cancel, we have 1 by 2. So therefore theta is equal to 60 degrees, pi by 3. So pi by 3 is not given, or pi by 6 to pi by 3. Okay, you don't take the modulus unless mentioned. 2 pi by 3 is there, leave it now. So if the option is there, don't take it, minus 1 by 2. This will be 2 pi by 3. That means third option is the right option. Third option is the right option. Okay, next one. Fourth one. If the circles of same radii and with centers two comma 3, 5 comma 6. That means center of the first circle is 2 comma 3, second circle is 5 comma 6. 5 comma 6. Cut orthogonally. Then the radius is. That means radius of each circle we need to find out. First option 3, second option is 5, third option 6, fourth option 2, fourth option 2. Right. If the circles of same radii with centers 2, 3 and 5, 6 cut orthogonally, condition is given. Then we need to find out radius of the circle. Let R1 equals to R2 equals to R. Now D equals to, say this is C1, this is C2. C1, C2. Distance between these 2 points. Root of 5 minus 2 square, 3 square, 3 square. This will be 9 plus 9, root 18. Since they cut orthogonally, they cut orthogonally. They cut orthogonally means we have R1 square plus R2 square is equal to D square. This is the condition. R1 square plus R2 square is equal to D square means you get R square plus R square is equal to D square is 18. So we have 2R square equals to 18. Squaring on both sides. 2R square equals to, D square equal to, not squaring on both sides, absolutely wrong. Okay. Now D square is 18. R square plus R square, 2R square is equal to 18. R square is equal to 9. So R equal to square root of 9, 3. R must be positive. So 3. So first option is the right option. Okay, tomorrow we shall continue the rest of the class. Just I have given today introduction, the few problems we have discussed. This is absolutely level 1 problems itself only. These problems you might have discussed in board examination. Thank you. Bye bye. See you.